Hello everyone. So I'm going to do a short video on section 1.3 and then I'm going to move on to section 1.4. So section 1.3 is on the direction field. You can call it the slope field or even a vector field, but the one that makes the most sense would be the slope field because given a differential equation, what you want to do is for each point, you want to plot the slope at that point. So this direction field or slope field really only makes sense when you're dealing with first order. Okay, so you need to be dealing with first order differential equation, because only then would you have the first derivative, and that's exactly going to give you the slope. Okay, so I'm just going to do this one problem. This is a problem from my math lab that was asked by a student. So here you have this differential equation dy dx is equal to negative 4x over y. And so that's your differential equation, and right away you see that this is a first order differential equation. And here's the initial condition. So first thing is we're going to create this slope field, and just to do a sample point. So for example, I use 2, 5 here, but I'm going to change it to 2, 4. So let's say the point is 2, 4. That means then your x is a 2, your y is a 4. So in place of x, I write a 2. In place of y, I write a 4. And so what's your slope? Cancels the 4, and so your slope is a negative 2. Okay, so negative 2 being the slope, I can view that as a negative 2 on top. And, well, that's the same thing as negative 2 over 1. Okay, so this is going to be the slope at the point 2, 4, where my change of y is a negative 2 and my change of x is a 1. So on this slope field, here I'm going to identify the point 2, 4, and that's right there. And in order to draw the correct slope, I'm going to use this change of y over change of x to help me figure out how steep I should draw my slope. So change of y being a 2 means that I go down 2. And change of x being a positive 1 means I go down by 1. So wherever my slope should be, starting at this point, I should be heading towards this second reference point. And so this would help me to kind of figure out how to draw my slope. So here's the point 2, 4. And at 2, 4, my slope is a negative 2, which means that it should be heading towards this other point, which is 2 below and 1 over. And you see that indeed it's heading towards this other point. So this slope is a negative 2. And if you keep on doing this for all the other points, you'll get something like this. And this is the slope field. And all it is just really a graph of all the solution, piece by piece. So all these are just small little bits and pieces of the tangent line along the solution curve. And so if I just follow along any of these guys, I would sketch out a solution. And if you look at it, it seems like all the solutions would be somewhat of an ellipse. So if I were to follow along these slope, it looks like it's a vertical ellipse because here your vertical axis is bigger than your horizontal axis. Okay. All right, so that's really what a slope field is. And the question is, sketch a few solution curve. And we're given three choices. You know that y of 0 is negative 3, which means that your solution curve should contain that point. So one thing you know is that when x is 0, we have y being -3. So that's the first condition. The second condition is that if you see it written like this, where given an x, you have only precisely one y, this is a function. Okay, that means at that x location, there should only be one y location. So here are the three choices. A, your solutions are half an ellipse. So you see something like this. B, it's definitely not B, because your solutions are not hyperbola, so it's not B. And then you have your C choice, which instead of being a half ellipse top and bottom, it's half ellipse left and right. Now, both A and C would actually be correct if you didn't have this initial condition. But if you notice, this initial condition is saying that for this particular x value, you only get one y. So here, if you zoom in on example C, you'll see that when x is 0, you're at 3, but you're also at -3. So how can this be a solution given that the condition is that at 0, you're only at -3? Here you have one of the solution curve being this guy, which is at -3. And this is exactly going to satisfy this initial condition. So it's going to be A. This is another solution. This is one of the solution that satisfy this initial condition. This is another solution. This is another solution. But if you notice, all of these solutions are functions. This is not a function. This is not even a solution. So all the solutions are actually A and C, but the solutions that would satisfy the initial condition is really only A. Okay, so that's my short video. If you guys have any questions, you can ask me when we have the Zoom meeting. Okay, my next video is going to be on section 1.4.